the stakes are actually pretty high on this evaluation. There's large price differences between AI models. If you look at the budget that people spend on different AI models, it's in the millions. And if you're talking larger companies, tens of millions or much more. Let's just say there's a reason that OpenAI is got to 1 billion ARR so quickly. It's that, they're not giving these model usage away for free.
How is AI evolving? How's AI changing the world of business? And why does all of this mean that experimentation is more important and relevant than ever? We recorded this conversation with Eppo CEO Chase Sharma and Head of Statistics Engineering Sven Schmidt to explore everything AI and experimentation.
All right. So today we wanted to have a conversation about AI and experimentation, experimentation in the age of AI. And we wanted to have this because if you look at what's happening in the industry right now, every single board is having some sort of AI conversation. Every single board director is. Every single company is trying to figure out what AI is going to mean for their business, for their ecosystem. There's some spectacular successes, a whole lot of confusion. Everyone's trying to navigate it. So in a way, I feel like what's really happening is everyone is experimenting. It's very hard to kind of sit down, read a bunch of blogs or talk to a bunch of people and know this is what AI is going to do for you. You pretty much have to just implement the thing and see how it works. And so, there's actually a few facets where experimentation and AI are attached to the hip. And it made us want to have a conversation around what's new and what's the same compared to, AI over the previous 10 years. So with that, why don't we start off, Sven, why don't you talk a little bit around, you worked at Stitch Fix. Stitch Fix is, one of the more forward-thinking algorithm-centric companies out there. As you eye this current age of AI and LLMs and everything, what do you think is the same and what is different compared to previous eras of machine learning and other types of models?
Yeah, that's a great question. We did a lot of machine learning at Stitch Fix, trying to fit all kinds of models on data on whether people would like a particular style, whether the size would be right, whether they would like the price. One thing that is clearly different now from the age of AI, I think, is it was really data sets that you would curate yourself, and you fit your own models on that. And there was a lot of internal development of models. And we started off pretty simple, right? Back then, right? You started with linear regression and it became more fancy sorts of regressions. And eventually it became transformer models and went from there, maybe some collaborative filtering in between. But there's a lot of internal development of technical models. I think one thing that is very different now, right, is that you no longer leverage your own data as much because you have these foundation models, right? And then you you put your own data on top of that, but in a very different way, right? You're retrieving relevant documents that are relevant to your use case, or you're fine-tuning these models perhaps on your own data. But you start with a very rigid structure. So I think that is quite different from what we had in the past. But in the end, right, what is the same is that we're trying to improve customer outcomes, right? And trying to provide a good experience, a better experience. And right in the end, that's what it's all about. It is about these business outcomes, right? And building a product that people love. And so you go back to, how do we do that and how do we iterate on that?
Yeah, definitely. I think this point around in the previous eras, you built your own models. It's a huge difference, right? Think of the expertise required to spin up a machine learning practice, to get all that data set together, which is a huge data engineering problem, to actually, build the models themselves, which requires ML engineers, a bunch of proprietary infra. And then you come up with this thing, and every time you want to improve the model, you have to continue to employ those people to kind of build these new models. Now, any sort of hobbyist out there, any sort of business user has a chat GPT-like interface and a bunch of APIs that they can just take a fully formed model and just immediately start getting value with it.
Oh, yes. Yeah, that's such a big change, right? You had to, because everything was homegrown and custom, you had people implement the models, but also the underlying infrastructure to serve these models. And you needed a feature store and you needed, caching to make sure it's fast. And now everything is just an API call to some foundation model company. And obviously, since the types of models have really shrunken to kind of one type of model, and we've just scaled that immensely, it is completely different from how we did that previously, and makes it much more accessible, right? We had kind of from doing everything homegrown to a bunch of ML ops companies that help you out to kind of now it's just an API call away. So the infrastructure needs to get started are also, it's not just that the capabilities of these LLM models are fantastic, but also just the barrier to entry is ridiculously small compared to what it used to be.
Definitely. And so in talking about barriers of entry, there's the barriers of entry of just building the model itself, which again requires so much less expertise. But then there's that barrier of entry to actually use the models where, the previous models were these highly structured, rigid schema things. They, you fed them, JSONs and you got numbers. And then, there's a whole bunch of surrounding stuff around the numbers to like lead to Airbnb search ranking, for instance, or, whatever application there are, smart pricing, whatever those applications. Now, these Gen AI models, it's sort of like you have like a pretty smart kind of college intern who like can speak your language and can Google a lot very fast and can take these like highly unstructured tasks and, actually produce things. So, whereas before it was the equivalent of like, needing some like highly trained investment banker to make a fancy spreadsheet. Now it's just like you can kind of just send an email to this smart college student who's then actually going to go and figure out a lot of things and produce like a full end-to-end impact. So, a huge paradigm shift that makes it dramatically more accessible.
Right.
So, in a way, I wanted to start there because AI is exciting, but I think that actually the interesting part gets into what's the same about the current generation of AI and the previous generation of AI. I have some thoughts, but I want to kind of have you start, Sven.
What is the same? Well, to me, right, is the end goal has not changed, right? It's in the end, AI and ML have been a means to an end, right? And we can have different ends now, perhaps in the sense that we can build stuff that we couldn't build before, right? Like I think self-driving cars falls in that sphere. It's not an LLM, right? But it is a capability that we're really have been working on for a long time, and we're getting to a space now where I can take a self-driving car back home, and that was not possible 10 years ago. So in that sense, the ends change, but in the end, we're trying to build great products, and so just the ways to do that have dramatically shifted. But I think in the end, we still want to do that. I'm curious what your take is.
Yeah, definitely. The way I see this, it kind of gets into what you meant by building a better product. The things that I think are actually remarkably the same are the sort of general approach to measuring the things, to measuring a Gen AI model versus a machine learning model. Because like what's in common here? They're both somewhat stochastic systems. It's true they can be idempotent, where like if two people give the same question, they might get the same answer, but it's not a very deterministic path where like, if you feed in this thing that, it's programmed to do that thing. And that kind of leads to this tough measurement problem, because if you have a big diverse pool of users doing a diverse set of actions against your models, like how do you actually know in aggregate what's working? And, that problem starts to look a little bit more similar to, the machine learning approach prior, where again, like you had these like very complex models that were going to take a whole bunch of inputs and make a choice. But it's hard to know kind of at scale what are all the choices going to be made across a diverse pool of users. So I know that's something you kind of faced quite a lot at Stitch Fix.
Yeah, and I think maybe it's a great point. I think that point is also a little bit hidden in the fact that a lot of AI applications are going from 0 to 1 at the moment. And from 0 to 1, you're not too careful about measuring stuff. You'll figure out whether you swim or sink, right? Yeah. Like that's fair. Like there's no experimentation needed. The whole project is an experiment, and that was obviously also when back in the day when you created something new with a machine learning algorithm, right? Often also it would be if you build a product around a machine learning model. You would also just see if it works, and it would be fairly obvious, right? And I think we see a lot of that now. But then as things, once you get traction, then there's always a long runway on improving that, right? Like, and that's where there was a lot of innovation in machine learning, right? In search at Airbnb, in our recommendation systems at Stitch Fix, and in matching algorithms at Uber, et cetera, et cetera. And right then there's this really long period of time of innovation where measurement and incremental improvement really matters. And I think a lot of AI applications aren't quite there yet. There's a lot of 0 to 1. But then if you look at the really successful companies, right, they really are starting to adopt experimentation. I think Perplexity is a great example of a company that clearly has had a lot of traction, and you can see them leveraging experimentation a lot now because they are at this stage that they know this product works. How do we make it work better? And the way to do that is obviously you can't improve what you can't measure, right? So you start measuring and then you start iterating.
Yep, completely. I mean, the point about 0 to 1 versus 1 to n is very well put. I remember Airbnb, the original search ranking model just had to replace a dumb heuristic. There was, literally just, listings had points and you rank the points, and eventually became something much more complex. And that, we just shipped it. But then immediately afterwards, search ranking became the most experimental team at Airbnb. That started to have to really understand like how do models perform against each other. And I think that models perform against each other bit is a bit of what we mean here, where it's like there's actually quite a lot the same. I mean, when Sven, you've dipped in this world a little bit. I mean, what are the types of ways in which you'd be comparing models?
I mean, I think, right, like in general, back then, I still think right now it's exactly the same. You start with some idea of how you think you can improve. You implement that idea and backtest it on past data, right? Ideally, you have that data once you have some traction and see if metrics improve. And maybe back in the days, the metrics look slightly different than they do now, or maybe they are exactly the same. And most of the time, you would find that your idea wouldn't work, right? Even on backtested data, and you try to come up with some other idea. But then, if your idea did work and did look promising in kind of looking at historical data, then you'd go and run an experiment to verify that this is actually the case, right? Because quite often, gains on historical data did not translate and still do not translate to business impact. And there's a variety of reasons for that, right? Like in some sense, we're overfitting to historical data, right? Like we use the historical data to come up with ideas. And so there's some overfitting there and just overfitting, just more the classical overfitting to that data. But also, the world changes and people interact in ways that historical data probably can't capture. If you change the system, you change the dynamics, that part is not captured in the historical data. So you need to try it out live, right? And see, like, if you put this in production, do you actually get the same gains? And in my experience, it's often still the case that it does not translate, or at least doesn't translate to the same degree. But hopefully sometimes it does, right? And then you win and then you start over, right? Then you go back to new ideas to try and improve what you just pushed.
Definitely. I mean, just to make the whole thing kind of very concrete, suppose, we are Perplexity or we are some company that has like a robust, AI product, something that we want to invest in more. I just saw they announced a new Llama model. And I want to know, Llama is a nice open source model, which is, beneficial in a number of ways. I'm currently using a GPT-4o model. What is that comparison going to look like? And I think it's worth touching on a little bit of like the current state of the art, which is a little bit more unit testy and heuristic, and then the how more sophisticated players tackle this problem.
Yeah, I think we see a lot of folks now focus on this evals thing, which seems to be AI speak for backtesting, right? Where you have a historical set of data. It is a little bit more complicated, right? Because the output is not as structured, right? You're not comparing a forecast with an actual value, but you're comparing perhaps some textual output with maybe you're trying to summarize some article and you compare it with some other summary that you think is the ground truth. Obviously, they're not going to be exactly a word-by-word match. So, figuring out how close that matches is a problem in itself, right?
It's worth spelling out, like, what exactly is an eval?
Right.
Yeah. So, the evals in the AI world, it's basically, if you think of like a simple unit test of saying like, give this prompt to my model and then it's going to produce an output. And then the funny thing is that, you'll probably use another LLM model to say, like, did this output match my idealized output to some distance?
Right.
Yeah. And so, that's kind of the thing we see most often.
Right. Exactly. And that's your idealized output, but is that also the idealized output of your customer, right? Is that what they're expecting? You're making a lot of assumptions when you create this, right? Anyway, maybe I'm getting ahead of myself.
Yeah. Yeah. So, that's kind of state of measuring these things. And, I think machine learning had its own kind of equivalents, right? The back testing, as we're talking about, you'd have a historic data set with some historic numbers, and you get to see which is the same. But I think, you brought up an interesting point, what I've been telling a lot of other folks, which is, at least in that previous backtesting world, you produce numbers, and you can know whether a number is close to each other.
Right.
Right. In the new Gen AI world, you produce a sentence. Even in the backtesting, like, simulation world, like, you have to lean again on the LLMs and to actually understand whether something's good or bad. So you end up with a kind of GPT scoring GPT sort of paradigm to actually even understand at a basic level, are these things on par with each other.
Yeah, in some sense, you're taking a bigger leap of faith, right? That this eval makes sense, right? You took a little bit of a leap of faith in the ML world, right? That this historical number actually still meaningful in the future, right? And from experience, we know that this is sometimes the case, but not always. But this leap of faith is certainly bigger.
Yeah. And the thing that always strikes me about this is, like, in addition to, again, the GPT scoring GPT problem, is that the stakes are actually pretty high on this evaluation. It's there's large price differences between AI models. Right. If you look at the budget that people spend on different AI models, it's in the millions. And if you're talking larger companies, tens of millions or much more. Let's just say there's a reason that OpenAI is, like, got to 1 billion ARR so quickly. It's right. That they're not giving these model usage away for free, except for the ChatGPT thing. So it's very expensive, and so there's real ROI of not just improving your AI strategy, outcompeting competition in a kind of efficiency-minded world, but also just saving a lot of money, to actually build the best products. So it always struck me that, like, if you were to be at a bar with some AI engineer after work and say, like, how do you feel about these models, how they outperform each other? I think you'd end up with a pretty honest assessment where there's not a lot of confidence in the way people are measuring things.
Mm-hmm.
So, that gets us into kind of the AI experimentation, connection. So new Llama model comes out. I'm Perplexity. What should I do to understand whether I should use Llama or not?
Yeah, I mean, I think you do start with that offline evaluation, right? And probably before even coding anything up, you'd look at, like, what is the cost? What are the capabilities? Does it look promising to begin with, right? The Llama one looks promising, but there's new models coming out every day. So you probably can't invest. You don't want to invest in everything at the same time, right? So,
and it's worth underscoring that how often new models are coming out.
Because there's the Mistral model today, right? So just one day
seemingly
after,
every few days, you're going to have a new model to make a choice about.
Right. So yeah, and then you can run. Obviously, you can generate your new evaluations, see how that works, and if that looks good, right? Perhaps then you want to, and you have the user base to support it. You might want to run an online experiment and randomize your users in between using one or the other. But it's not just about which model, right? You could also think about changing the prompt, changing how you retrieve your documents, right, that you base your outcomes on. Like, I think there's a lot going on that you can be changing at the same time. There's specialized smaller models that you're fine-tuning versus larger models that you can't fine-tune. So the options are really limitless.
Yeah, and it's getting into the details of these sort of A/B tests. I think one of the things that is so different about that environment versus the evals is the metrics you're actually tracking.
Right.
And so, I think what I see with a lot of AI teams is, like, if I'm not supposed to do evals, what should I be doing? Well, the beauty of doing the randomization thing is you can end up with this kind of rich 360 view of your business, right? You can get a very localized around your AI model thing around, like, a thumbs up, thumbs down, were these good prompts? Did the AI model return real language? You got a chatbot, were you happy or upset with this interaction? Then you have kind of a more business-minded view, which is, like, is the chatbot actually saving you money? Is it actually leading to lower filed tickets because they can actually just talk with the chatbot? And then there's in terms of de-risking everything, if you have some measure of toxicity or some measure of, some other kind of liability sort of measurement, then you can also track that in the A/B test and see the new llama came out, it might perform better in a general sense of accuracy, but it's very easy to make it go rogue and suddenly be antagonistic. Now, I'm not saying, I'm sure llama is quite good, but it's always a concern every time a new model comes out. So, I think that AI and experimentation have always been so closely tied at the hip in that way. But I think the interesting thing that, you and I have talked quite a lot about is, okay, in the short term, there's going to be a lot more A/B experimentation to measure these things because it's so easy to deploy. So there's going to be way more AI than there was machine learning. And these things are basically inscrutable because they produce text instead of numbers. And so we got to check how these things do against my business metrics. But outside of just measurement, AI is also just kind of an interesting technology in terms of, innovation.
Right.
So tell me a little bit around kind of what you see as second order effects around AI and how it's going to affect, us in the measurement business.
Right. I think you're pointing at the fact that not just do we have these models that create new businesses, right, business ideas or enhance current ones, but they also enhance productivity, for example, right? Like engineers have code assistants that are making them way more productive, making it faster to put something in production. And so that might mean that even companies that have nothing to do with AI are able to innovate a lot faster, might be able to try ideas where previously they could try one idea. Now you could try three because your engineers are more productive. So I think that's one side. And then the other side, of course, is that a lot of ideas can be generated by AI as well. And think about whether that's copy on your marketing website or perhaps soon, right, even TV ads that might be generated by AI. And now, it might be tricky to randomize TV ads because we know that is a tricky problem, but you understand that, we're getting into a world where generating creative assets might just become a lot less costly. And so we can try a lot more ideas too, even if, you might not be in the business of building a business around AI.
Totally. I mean, think the problem of producing marketing collateral and understanding what marketing collateral is working, it's a very universal one, right? Every business of every stripe has that. And suddenly, instead of having to do an arduous journey with a agency to produce 3 pieces of collateral they have to decide between, it might be trivial to produce 1,000. Exactly. An age of abundance of creative assets is that's already here, right? We're not even extrapolating very far in the future. And so there's a whole question of how should we evaluate all these creatives, which, touches on some of the bandit conversations we've had before. If you have a lot of things to measure, you got to be more automated in how you do it. But I think it's also interesting to talk about, even outside of creatives, what are LLMs really good at? They're good at brainstorming and they're good at coding. Together, what do you have? A growth experiment.
Right.
So, I think it's kind of interesting to dive into, where does this all go for, the world of deploying more experiments?
Yeah. So, I mean, when the cost of innovation goes down, ideally, right, you also want to make sure your experimentation and your testing of these ideas, right, the cost itself of testing also goes down. And I mean, taking a step back a little bit and maybe a little bit of a tangent, but I remember when I first started at Stitch Fix, we didn't really have an experimentation platform. And what that meant is we had to go and add rows to a Postgres database, right, to run an experiment. It was very costly, and it took 3 months to run a single experiment. And, you could have a million ideas, but it didn't matter because, you could test one every 3 months because we didn't have the infrastructure. And every year, right, we improved upon lowering that cost. And that means that you can test way more ideas. Now that we really have opened the floodgates to all these different ideas, right? If we can also lower the cost of running many experiments so that we have the capacity to test all these things, then we can really innovate a lot faster.
Definitely. And it's funny because, you're comparing to your early Stitch Fix days where at least, hey, you were still running experiments.
Right.
And look at the state of the art of how decisions made on like what is the best creative asset works at companies who don't run experiments. You're going to have a committee. They're going to stare at all these things. They're going to have a debate and votes and stuff, right? Eventually it's going to be the kind of highest paid person, the hippo, who's going to actually decide these things. So already in the world of software, we have found that the fastest companies out there, the Hermes, the Facebooks, the Netflixes, are able to run laps around their competition because they just have a much more streamlined way of making decisions, which are A/B tests. But now even those companies are going to have the deluge of new ideas to test. That's going to stretch everyone's kind of capability to evaluate those ideas. So I think one of the quick sort of evolve or die sort of paradigms that's emerging is if the way you decided what ideas to implement and what ideas to launch was via committee or via like a PRD or some sort of like human kind of get together, talk about it process, that's not going to cut it anymore.
Yeah. And I think one thing that is interesting about this whole design by committee or experts versus what you can do with AI is that, maybe in a data-driven way, you can find the best single asset better than an expert, but maybe you can't. Often experts know pretty well what kind of works generally. But what is very difficult, I think, right, is covering the entire space of preferences, right? How do you make sure you cater to everyone and not just the average person, right? There's this famous anecdote of like, there's no pilot that fits in the average flight suit, right? Like everyone is different in a slightly different way. There's from the 40s, I think they did research of what flight suit sizes should look like. And I think that's the same here in that, partially it is about catering to a wide variety of preferences that is way more feasible when you're able to efficiently explore, kind of create so many assets. And, they might only appeal to a couple of people, but if you can find these people and target them, that can be, you can get a lot of gains out of that.
Definitely. And so as we get into the, how do we evaluate all these new ideas? I think that, the word I keep coming back to is automation. Mm-hmm. Much more automation. And I know, we've had a lot of conversations with, the people in kind of the most cutting edge experimentation platforms. And, that's the kind of word they have all in their minds. So, if you think about a much more automated world of deciding between AI model ideas, what does that look like to you?
Yeah, I think there's a couple of things, right? Like you can go back to automation really through quite literal automation, right? Think about bandits, contextual bandits that just kind of take over. Or you can think of automating in a way of standardizing, right? Where perhaps you still run experiments, but you lower the cost, make it easy for everyone to run an experiment following a given plan where the kind of process is laid out, the decision criteria are decided upfront, or perhaps even just the same across many of these experiments. I'm curious what your take is from what you've seen talking to folks.
That's pretty much it. I mean, I think we've gotten very used to a world of babysitting A/B tests. Mm-hmm. And I think that is also in the evolve or die world, is going to kind of show its age. Where there's going to be a set of experiments which are truly kind of, high stakes, high scrutiny things, very collaborative, that might have a lot of humans circling around it. But when it comes to which of the 1,000 creative assets are we going to use, I really do expect a lot more kind of bandit auto experiment type paradigms to emerge here.
Yes, in some sense, this new advances in AI made it possible for a lot of people to build cool stuff. Now we also need to make sure that all these people can test and can iterate, right? And make that equally accessible to how easy it is to build things.
Yep. Cool. All right, well, we covered a lot of ground here. I'm very excited for everything that this age of AI is going to bring to humanity, and hopefully that it kind of gets everyone to really appreciate what does kind of systematized, structured, fast decision-making look like. Because, again, the stakes are high, monetarily and existentially for a lot of these companies. So excited we can cover a lot of ground.
Yeah, fantastic.
So obviously it's great that businesses are running lots of experiments, but the question that everybody eventually wants to answer is how do we quantify at a meta level the impact that all these experiments together are having on our business? And even better if we can break it out by all the different teams that are experimenting and understand the impact that we're having. I know that's part of the reason why Eppo built team scorecards, but maybe you can talk to us a little bit more about like the impetus behind scorecards.
Yeah, definitely. I think the big point with team scorecards is that we at Epo are very rigorous in understanding whether experiments are successful or not. But they're experiments, right? Definitionally, a bunch of them are not going to be successful. What companies actually care about are that teams are successful, initiatives are successful, that teams and initiatives, they execute well, they ship, and they operate with like high standard of craft and ultimately deliver impact. And so team scorecards is really a kind of homage or statement to those leaders who want to know, are my teams executing well from a process and outcome standpoint? But the tricky thing with kind of aggregate scores of teams is kind of how exactly do you do it? And especially because, the big one's impact. I think like if you have impact, if you drive metrics up, if you increase revenue, decrease loss, like no one asks that many questions, right? But that unfortunately is sort of a hairy problem. It's been you've had quite a lot of experience in that sort of area.
Yeah. Before diving in there, I do want to double click on what you said that I think is important, is that a lot about experimentation and what's so important, right, is going away from the having a goal of shipping something to having, we know we want to try ideas and we want to try these ideas and some might fail. But it's hard to gauge performance when you know that some of these things may fail. So you really do want to, if you want to efficiently move organizations away from just like evaluating and promoting shipping things, you need to come up with a valid alternative to that. And like just single experiments and whether they're successful or not are not very good at that, because that's not the point. And so I think that is right where these scorecards come in, is an alternative to valuing just shipping features, which is, I think, very detrimental to this experimental mindset. Okay, but then onto your question on how to evaluate impact. And that is tricky because there is randomness, right? We're experimenting. Some things work, some things don't. So there's the inputs to that, but then also you can look in aggregate across many experiments, obviously, whether a team is making progress or not. But still, that is hairy, right? Because we know of things like the winner's curse, where your winning experiments are likely upwardly biased due to the fact of them winning the experiment, right? That they had a lucky coin flip somewhere along the way, or maybe many lucky coin flips, and how many kind of depends on how well powered these experiments are. And so you want to take that into account and kind of, you can't just take all the experiment wins at face value. You have to correct for the fact that they are overestimating the value. There could also be that two experiments in isolation are winners, but when you add them up, they really solve the same pain point. And so you're solving a single pain point twice. You can only really claim the credit once, right? So I think the gold standard that the most sophisticated and large-scale companies have adopted quite successfully is holdouts, right? They run a holdout where they basically run the aggregate of all winning experiments again on some held out traffic that has never seen any of these experiments or any of these features, and then see, right? Some of them will now see the combination of all winning variations, and some will still be held back from all of it. And then you can compare these two. It's another experiment, right? It's an experiment to evaluate all your experiments. So in some sense, almost a meta experiment. And that is the gold standard to measure aggregate impact. But it obviously comes with some downsides in that you need to keep your old code around. It takes a long time, right? You have to first wait to maybe the quarter to get all your wins and then run this holdout for another month, perhaps, or maybe another quarter. So it takes a long time, right? And so with making your engineers unhappy and then having to wait a long time, that is tricky. So you can look at other things you could do, right? So perhaps you can use some mathematics to correct for this winner's curse. I think Bayesian statistics in particular is pretty good at this because it it generally has some shrinkage built in, right? So it shrinks your estimates towards zero, just like you would do if you take a haircut of your estimates. And so you can leverage techniques there to get a sense of the aggregate impact in a more unbiased way if running a holdout is infeasible.
So if we have our impact quantified on metrics, I guess what else do business leaders need or want to look at besides just the outcomes or the outputs on these team scorecards?
Yeah, definitely. I will kind of double click on one thing. When I talk to a lot of chief product officers, product leaders, probably the thing that bugs them the most about experimentation are two problems. So the first is that this team is claiming that they drove my metric by like 15%, and they just didn't. I know, like they just didn't. Like, I add up all these experiment results. I do not feel like, the business has changed to a 15% degree. And it turns out like, a lot of the statistics people use never promised that you could add up experiments. That was never something that actually statistics says, that you can just add up, I got 1% here, 2% here, 1% here. And it's all due to, the sort of problems Sven mentioned around like, sometimes experiments got kind of temporally lucky, like it works in the summer, but not the winter. Sometimes they just get, lucky out of just noise and variance. Underpowered, low sample size tests will often have inflated point estimates. And so, but the problem is that it's such a core part of the culture to know what is the total impact of a team. And so it's worth getting right. So that's the kind of the problem I hear most of all, and it gets such like emotion out of a product leader is like, how do I actually know what the impact of all this investment was? But the second thing I hear the most from product leaders is I just see experimentation and I find that people are running like low quality tests. They're kind of using it as a crutch. They're doing spaghetti at the wall strategies, just throwing spaghetti at the wall, see what sticks. They are, I know enough about experimentation to know that they're not doing it properly. So, just getting some sense of like, are they actually running good experiments, and are they running a sufficient number of good experiments? So, when we think of team scorecards at EPO, first there's the impact assessment, which has, holdouts, winners curse adjustments, Bayesian approach. The second is experiment volume, because, even though we care about impact more than shipping, you don't get impact without shipping. So you better ship enough so that understanding only 30% of what you launch is going to work, you still have enough experiments that you're going to get enough impact. But then the third thing is on this quality side, which is, when you run an experiment, are you hypothesis driven? Are you actually starting off with a statement that, if this is true, then we could drive some impact. And once you have an actual hypothesis behind things, then are you running the experiment properly? Are you using the right metrics? Are you following protocol on how to actually balance those metrics? Are you waiting long enough to get enough sample size? So, introducing EPO team scorecards, we are going to be, helping product leaders understand, are teams shipping enough to get impact? Are they running experiments for long enough? And with a lightweight kind of a hypothesis grading system to understand, like, is there actual thinking going on underneath these experiments? And all of this rolls up into kind of a much, much more rigorous treatment around the aggregate impact of teams.
Thanks for listening to this episode of Outperform. If you enjoyed the discussion and want more content about using experimentation to drive innovation and growth in your company, visit getepo.com/outperform. Your journey towards building a winning company and career starts here. Until next time, keep experimenting.